voltage here is V1, this voltage here is V2, and this voltage here is V3. And the current that is supplying the combination is equal to 4 amperes. So calculate the battery voltage V, no? Pila ko ng supply voltage, the total resistance of the circuit, and the value of resistors of R1, R2, and R3, given that the potential difference, so that's voltages across R1, R2, and R3 are 5 volts, 2 volts, and 6 volts respectively. Okay, so this will give us the opportunity to solve using what we have discussed earlier on the formula for series. So for letter A, so what is asked is the supply voltage V. So this one, no? How much is the battery needed, no? If you have 3 voltages connected in series, 5 volts, 2 volts, and 6 volts. So again, for series, the total voltage is equal to the sum of the voltage drop or the voltages in the series. So that's V1 plus V2 plus V3. And that is 5 volts plus 2 volts plus 6 volts. So this is equal to 5, equal to 2, and this is equal to 6 volts. So that is equal to 13 volts. That's for letter A. For letter B, the total resistance of the circuit. So the total resistance of the circuit, let us use the subscript T for total. So total resistance. So total resistance, that is equal to R1 plus R2 plus R3. But in this case, we don't have yet R1, R2, and R3. So the longer solution would be to solve for R1, solve for R2, solve for R3. Now that would be the longer solution. But the shorter solution would be to use the total. So to use the total. So instead of the value for R1, R2, and R3, that will take time. Na naman tayo nakuha ng total voltage, that is 13 volts. RT is equal to VT, the supply voltage, over total current. So in this case, VT, atoling subscript VT, is equal to 13 over the current, that is 4, so that this is equal to 3.25 ohms. So for series, mudako ang imong resistance, ang total resistance, which is opposite to parallel. Later on, kita nyo, ma-identify mo. Okay? Then, letter C, what is the values of resistors R1, R2, and R3? So, R1 is equal to V1 over I1. Okay? Where I1 is equal to I2, equal to I3, equal to total current, equal to 4. Therefore, R1, so I continue, R1 is equal to V1, that is 5, volts over I1 equal to 4. And this is equal to 1.25 ohms. Same process for R2, that's V2 over I2. Again, I is the same for our supply, and that would be 2 over 4. That's 0.5 ohms. And R3 is equal to B3, that is 6 over 4. So that's equal to 1.5. So if you take the sum of all the currents to verify your answer, that should be equal to 3.25. Okay, so that's the answer. For example number 2, for the circuit shown, determine the potential difference across R3 if the total resistance of the circuit is 100 volts or 100 ohms. Determine the current flowing through resistor R1 and find also the value of resistor R2. Okay, so what is asked is potential difference, no? Pila ni siya. Then next is the total resistance, the current flowing in R1. So pila ko ni current 3, I1, and find also the value of R2. So those are the things that we need to solve for this example. Okay, so how do we solve for B3? So let us examine the conditions. You can solve V3 through this following formula using current I3 and resistance R3. But none of the two, I3 and R3 are given. No? So you can also solve for B3 from the formula B total equal to B1 plus B2 plus B3. So you have BT, that's 25 volts, B1, 10 volts, and B2, 4 volts. Therefore, we can solve for B3. So we will be using this instead of this. So that V3 is equal to VT minus V1 minus V2, and that is 25 volts minus 10 volts. No? So 25 minus 10 minus 4. Okay, that will give us 11 volts for our V3. Next is R2. Okay, so how do you solve for R2? So if I'm going to solve for R2, that would require the current. So R2 can be solved if you have current, because not a V2 and divided by I2, then you can solve for R2. So that means that I would first solve for I1. No, I'd rather solve for I1 first, knowing that I1 is so anon po gyapon, no? So di gyapon din nato madiretso, but we can get the relationship that I1 is equal to I2 equal to I3. Therefore, your I3, since we already have, do we have R3? Wala, no? So wa gyapon. We'll make use of the additional given parameter. So we have the total supply of 25 volts, but we don't have the current. No? The total resistance is given. So natay RT. So in that case, RT or IT is equal to V total over R total. And that is 25 volts over given resistance 100. So the total current is 25 over 100. That's 0.25. Okay. So 0.25 amps, where IT is equal to I1 equal to I2 equal to I3. So therefore, I1 is equal to 0.25 and I2 is likewise equal to 0.25. So therefore, your R2 is 4 volts over 0.25. So that is 16. No? So that's 16 ohms. Okay. So 16 ohms. So solve na tanan. Okay. So your V3 is 11 volts. Your R2 is 16 ohms. So palain R2. R2 is 16 ohms. And that's all, no?
Current, sir.
I1, no? So sorry. Current I1. Kanya itong solve. Pangita. Okay. So, example number 3. So, daghanan na itong example, ha? Karon familiarize with that. Anyway, lalayam sa lagi pangita. So, at least na may reference. A 12-volt battery is connected in a circuit having 3 resistors connected, no? Series connected resistors having resistances 4 ohms, 9 ohms, and 11 ohms. Determine the current flowing through and the potential difference across the 9 ohm resistors. So what we are required to solve is this voltage here and the current in this resistor. No? Let us call this as I2. No? Anyway, kamaray mo kuan magbuot sa inyong subscript. Anyway, assumption na nato ang R1, R2, R3. So that is current I2. And find also the power dissipated in the 11 ohm. So power of the 11 ohm. So those are the required values or parameters. So first is, can we solve for the voltage V1? So di na to madirekta, but una na to makuha ang current, no? So total resistance RT is the sum R1 plus R2 plus R3, so that this is equal to 4 plus 9 plus 11. This is equal to 24 ohms. Okay, so that current I is equal to voltage over, so total voltage over total resistance, the total current. So that is 12 volts over total resistance, that's 24. So this is 0.5 amps. Okay, so that's I total, where I total is equal to I1, equal to I2, equal to I3, and that is equal to 0.5 amperes. So therefore, I2 is equal to 0.5 amps. So these are the known. We can now solve for B1. Actually, ato lang tangan na B2 ni siya, no? So we can now solve for B2, where V2 is equal to I2 times R2, and that is equal to 0.5 times 9, and that is equal to 4.5 ohms. So,
Sir, dili volts, sir. Kay
volts,
voltage man, sir.
Okay, sorry. So for the next unknown, solving for the power, at the 11 ohm resistor. So you can use BI, you can also use I squared R, for the formula. In this case, if you solve for BI, if you use BI, then you still need to solve for B. Okay, but you can also make use of the formula because V is I times R. So B is equal to IR, so that this becomes I squared R. So this is actually the power loss formula, I squared R. So that the current I, so shall we say R3 here, that's I squared 3, I3 squared R3, and that is equal to 0.5 squared times 11, make this 2.75 watts. So this is the power dissipated at the 11 ohm resistor. Okay. So for the total power, how do you solve for total power in the circuit?
I squared total over R total. I
Yes,
times the A.
times
Times.
R total. So you actually you evaluate the given or the already solved parameter and make use of these values. So you can use VI because we also have 12 volts and we also have the current already solved, 0.5, or you can also use the I squared R. Or the other formula would be to solve for the individual powers, so power across the 4 ohm resistor. the 9 ohm resistor and the 11 ohm resistor. That I would not recommend the third process because there are other shorter ways using the voltage and the current and the total resistance. Okay. So so far, any questions with regards to basic series or simple series? So if you're asked to solve for the power loss at the power absorbed by the 9 ohm resistor, that would be current I2 times the solved voltage V2. No? That's one process. Or you can use the I2 squared times 9 ohms. Same with the power across the 4 ohm resistor. Okay. So let's proceed to voltage divider. We call this voltage divider circuit or voltage divider. So series are termed as also voltage divider because as what I have earlier stated, that that series the total voltage will be divided among the series connected parameter or circuit components. No? So if you have two resistors R1, R2, then the total voltage will be divided among R1 and R2. So as to how much is for R1 and how much for R2, it will depend on the magnitude of R1 and R2. So the resistors with the bigger magnitude will have a bigger voltage drop. And the resistor with the lower resistance will have the lower voltage drop. Okay, so V is divided among R1 and R2. That's V1 and V2. So if you have three resistors, then the voltage will be divided among the three resistors. That's V1, V2, and V3. Okay, so for example, kasi kanang sa series lightings. So kanang sa series lightings, if you have 100 bulbs and normally they are connected across the 220 volt supply, if you have 100 bulbs, that means that 100 or each of the bulb will have a voltage of 2.2 volts for a 220 volt supply. So you divide and so 220 divided exactly among the 100 bulbs. Parehas mo sila wattage kada isa, so divided equally. So that is 220 over 100. That's 2.2 volts each. Okay. So that's why series sila, no? But sa atong ordinary loads dili pwede. Kay kana atong load nga suga required na siya og 20. So if you connect them in series duha, that will draw 110 volts each. So if you connect two identical lamp, so across ito 20 volt supply, each lamp will draw 110 volts. So if the lamp requires 220 volts to operate, dili na sa musiga, no? Di na mandar. Muna nga kung katong bumbilya sa una, musiga to siya pero gamay ang iyang hayag compare sa kuan. Pero kung gagamit ka ng mga electronic ballast or mga LEDs karon, that will not operate because it requires 220 volts. So for the voltage divider, V1 equal to R1 over R1 plus R2 times V, supply voltage, or V2, voltage across resistor 2, that is R2 over R1 plus R2 times V. Or you can make use of this no? You don't have to memorize, but you can familiarize yourself with the derivation, how this come about, no? So that kanang ato ang current, no? So that ang current ato I1 is equal to I2 equal to I total, no? So I total. So meaning I1 is equal to I total. So that kung yung I1, that's V1 over R1 Yun po ka I total, that's V2 over R total. Okay? Solving for V1, that is V total or supply voltage times R1 over RT. But RT for series is R1 plus R2. No? Making this V1 no? So making this V1 equal to VT R1 all over R1 plus R2. So that is how this is derived at, no? So kani, ito sa pag-derive. Same with V2. When you see I2 equal to I total, that is V2 over R2 equal to V total over R total. So that V2 is simply equal to VT, so supply voltage, times the resistance of the unknown over the total resistance, R1 plus R2. No? So, for example, if you have 3 resistors, no? If you have 3 resistors, so that will not change the numerator. For example, if you have V2, you solve to V2 for 3 resistor series, that will not change the numerator. That will only change the denominator here. No? So, mahimo na siyang R1 plus R2 plus R3. Kaya total resistance nimo sa 3 resistor series is the sum R1, R2 plus R3. But the numerator, that's still supply voltage times the resistance of the unknown, resistance of the unknown voltage V2 equal to the sum R1 plus R2 plus R3. So, example, because solving for V3, if you have 3 resistor, that would be VT times R3 over R1 plus R2 plus R3. So, bisang pag-upat pa na kabuo, ang mausap na is ang numerator lang. Mapuna ano, ika-upat nga component in series. So, R1 plus R2 plus R3 plus R4. Okay? So, voltage divider does not only represent or does not only mean that 2 resistors na siya. Voltage divider is another term for series. So, another term na siya used for series. So, series na gina. Okay. So, example, 2 resistors are connected in series across a 24-volt supply, and a current of 3 amperes flows in the circuit. If one of the resistors has a resistance of 2 ohms, so determine the value of the resistor of the other resistor and the potential difference across the 2 resistors. If the circuit is connected up for 50 hours, how much energy is used? So, 2 resistors in series across 24-volt supply. So, kani siya, sample ani, ato lang, no? Ato lang yung circuit. So, the supply voltage is 24 volts. If one resistor is 2 ohms, so let us say kani ang 2 ohms, what is the value of the other resistor? Tawag ng R2. No? And the potential difference across the 2 ohm resistor. So pila ko na potential difference rin. Okay. So the total current flowing is 3 amperes. So, ang current diri, call this I1, current diri, call this I2. Okay? So that I1 equal to I2 equal to 3 amperes. Okay? So, how do you solve for B1? B1 is equal to I1 R1, or that is 3 times 2, that is 6 volts. Okay? So that RT is equal to VT over IT, and that would be 24 volts over 3 amps, that is equal to 8 ohms. Okay? So, we can now solve for V1. Nanami V1 to, no? So, that could have been one solution using voltage divider. So, wala na ito magamit ang voltage divider. So, ito lang i-verify, ito lang i-check. Let us check our solution using voltage divider. So, voltage divider V1 equal to V supply times R1 over RT. Diba? So, ato lang nag-expand ng R1 over R1 plus R2 on denominator, but that is RT. Okay? So, our supply voltage is 24 times R1, that's 2, over R total, 8. No? So, diba 6 volts? No? Okay. So, how about R2? So, there are a number of solutions for R2, no? Pagkuha sa R2, pwede na mo gamitan ang subo ng naglahi nga V2, divide mo sa I2, mana na R2 nimo. So, applying voltage divider, or pwede sa simple subtraction. Okay? But atong gamitan ang kuan. Atong gamiton ang kaning voltage divider nga formula, no? Voltage divider, so that V2 equal to V total R2 over R total. No? So, okay, but we don't have V2 yet. So, supposedly, after masolve itong V2, and then by cross multiplication, that is V2 RT over VT. Okay? So, if we have V2, then makasolve na sa kwan. V2 is equal to I2. Ang dili, no? Dili. V2 is equal to V total minus V1. And that is equal to 24 volts minus V1, 6 volts. So, this is 18. Okay. So, R2 is 18 times RT, 8 over V total, that's 54 volts. So that is 6 ohms. Okay. So R1 is 2 ohms plus 1. Pwede sa mo ang R2 solve using RT. RT minus R1, that's R2. No? So I choose lang galing ang solution to emphasize the voltage division formula. But during exam, you have to choose what's convenient. No? So, ano lang, convenient din mo solution. So, we have here your assignment. Assignment number 2. So, talon ka item. This will be submitted on Friday na lang, no? At least taas yung one. So, di mo ma-pressure sa time. Sinapamilit ang mga assignments sa mga subjects ninyo. Basta submit sa Friday, not later than the time sa ito ang schedule before sa midterm exam. No, muna ka deadline. Any submission after